Hi everyone, this is a lesson for 2.2 reference angles. So let's take a look at our formulas. So today we're learning about reference angles. And reference angles are the angles formed by the terminal side of our angle and the x-axis. So if we take a look in quadrant 1, here's our angle theta. So the reference angle would be the angle that's formed between your x-axis and the terminal side of that angle theta. So in quadrant 1, those two things are exactly the same. So our reference angle that we denote with theta prime is the same thing as our theta. In quadrant 2, though, it's a little bit different because our theta starts positive x. Here's the terminal side of it and landing in quadrant 2. So our reference angle is the angle between that terminal side and the x-axis, so this one right here. So the way we would figure that out, how big that measure is we would take what it is to get to the x-axis and minus what part we're taking away. So that way we just have the part between our terminal side and our x-axis. So our reference angle in quadrant 2 is found by doing 180 minus our theta. In quadrant 3, here's our reference angle going all the way down to our terminal side. And this time our theta is right here between the x-axis and the terminal side of that angle. So what do you think we would do to figure out how big that piece is? Very good. We would do theta minus 180 because theta is the whole thing and we're taking away that part of it. So what we would have left is theta prime, or the reference angle. And for quadrant 4, our reference angle goes, or our theta goes all the way over here into the landing in quadrant 4. So our reference angle is just that piece between the positive x-axis and the terminal side. So to find the reference angle in quadrant 4, we would have 360 minus theta. So as you can see, all of our reference angles are found by using our x-axis numbers. So we never do 270 or 90. It's always 180 or 360. Okay, so let's take a look in the bottom at our examples. So when we do these, we would try to figure out first what quadrant we land in, and then we could see what formula we have. So 218 is going to land in quadrant 3. So in quadrant 3, we find our reference angle by doing our angle minus 180. So 218 minus 180 would give us 38. So that means that this angle here between the x-axis and our terminal side is 38. So for number 2, our angle lands in quadrant 3 or 4. So in quadrant 4, our formula says 360 minus our theta. So 360 minus 294 would give us a reference angle of 66 degrees. So for questions 3 and 4, we have the problem where they're not in between 0 and 360, so we don't know exactly where they land. So the first step would be to subtract to get them between 0 and 360, determine what quadrant they land in, and then do your reference angle equation. So go ahead and pause your video and solve for example number 3 and 4. So if we take a look at number 3, it's ended up landing in quadrant 2. If we subtract 720, we get 163. So 180 minus that is 17. So our reference angle is 17. In quadrant 4, we had to subtract, or in number 4, we had to subtract 1080, which gave us a reference angle of 307, landing in quadrant 4, so our reference angle of 53 degrees. Well, let's see what else we can do with reference angles. So a lot of our problems today will be based off of your special right triangle values, so we have to be pretty familiar with those ratios and what angles they go with. Okay, so for our first example, it says to find all of the trig function values for the angle of 210. So we haven't done 210 yet, so we have to figure out where it lands, see if it's one of our special angle values, and then we could draw the triangle from there. So we know that 210 is going to land in quadrant 3. So here's my 210. So we need to figure out what our angle is going to be here so we can make a triangle. So in quadrant 3, it's theta minus 180. So our reference angle is 30 degrees. So that means that this angle in here is 30. And now we can build our triangle off our 30, 60, 90 triangles. So across from 30, we have -1, and it's negative because it's in quadrant 3. So this would be our 60, so across from 60 is √3, and across from 90 is 2. So those numbers all come from chapter 2.1. So if you need a refresher on how we got those, check 2.1, or you can ask me in class tomorrow. Just make sure you don't forget. So now from that, we can find our sine, cosine, and all of our values using our picture. So the sine of 30 is opposite over hypotenuse, so -1/2. The cosine is adjacent over hypotenuse, so -√3/2. Tangent is opposite over adjacent. We'd have to rationalize, so we would end up with √3/3. And then we would just flip those to get our other values. So we would have -2, -2√3/3, and √3. Okay, so I would like you to try the next example. We do the same thing. So figure out which quadrant you're in, find your reference angle, and then draw your perfect triangle. It's either going to be a 30, 60, 90 or 45, 45, 90, and then you can find all your trig values. So go ahead and pause and try that next example. Okay, so we found that our reference angle was 45, and I know across from 45 is 1, since in quadrant 2, -1, and square root of 2 for our hypotenuse. So from there, I just found all my trig values using SOHCAHTOA. If you have any questions, make sure you write them down, and we can talk about them in class tomorrow. So if we take a look at the 4 boxes to the right, this is kind of doing the same thing, except it's not asking for everything, it's just asking for one value. So for the first example, it says the cosine of -240. Whenever we have negative angles, I would always suggest finding the positive coterminal angle first, and then seeing what you have from there. So if we add 360 to that, we end up with cosine of 120. So we know that 120 lands in quadrant 2, so we can draw our triangle just like we did for those last 2 examples. So here's our 120. In quadrant 2, to find the reference angle, we do 180 minus 120, so that means our reference angle is 60. And then we can build our triangle based on what we know about the 30, 60, 90 triangles. So across from 60 is square root of 3, adjacent is -1, and hypotenuse is 2. So the cosine of that would equal -1/2. Okay, so we'll do the cotangent of 780, and then you can go back and try those 2 by yourself. So this is a little bit harder because it's a bigger one, so we need to find the coterminal and its cotangent. So what I would first do is find the coterminal angle. So if cotangent is 780, that would be subtracting 720 or 360 twice, and we would end up with the cotangent of 60. Okay, so 60 is in quadrant 1, so we don't have to even worry about reference angles because we're in quadrant 1 and the reference angle equals theta. So our angle here is 60. So across from 60 is √3, across from 30 is 1, and the hypotenuse is 2. So we're trying to find the cotangent of 60. Well, the tangent of 60 is equal to opposite over adjacent. So the cotangent equals adjacent over opposite. So that would be 1 over √3. But if we rationalize, we end up with root 3 over 3. Okay, very good. So go ahead and pause and complete those other two examples. And when you come back, I will show you the answers. Okay, welcome back. I hope that's for the tangent of 675. We saw that that's equivalent to tangent of 315, landing in quadrant 4 with a reference angle of 45. So tangent, opposite, adjacent gives us -1. So for the other one, the sine of -150, our coterminal angle is 210. So 210 has a reference angle of 30, so we end up with -1/2. Okay, so let's take a look at those bottom examples and see what they're all about. Okay, so this one says to find all the values of theta given that the cosine of theta equals negative square root of 2 over 2. And theta is in between 0 and 360. So we have to remember a smart trig class, and we have to remember what this root 2 over 2 is about. Okay, so cosine is negative. That would make us land in quadrants 2 and 3. So I'm going to draw a triangle in quadrant 2 and quadrant 3. So if you're good at remembering all your special values, then you probably know already what our angle is. But whenever we have square root of 2 and over 2, that has to do with our 45. But it's rationalized. So if we take a look at our square root of 2 over 2 and we try to unrationalize it, so we're kind of just going backwards. So we'd have the square root of 4 over 2 root 2, which means 2 over 2 root 2. And if we cancel out those extra 2's, we have 1 over root 2. So that's what we're more familiar seeing on our triangles. But our final value would have been root 2 over 2 because we have to have those rationalized answers. So if we have the cosine of theta equals negative root 2 over 2, that's the same thing as saying the cosine of theta equals -1 over root 2. This is just the unrationalized version of that same number. So this is the one that I'm going to fill in on our picture. Okay, so cosine is adjacent over hypotenuse. And so we're in both of these quadrants because cosine was negative, so I'm filling it in for both. So if we do the Pythagorean theorem, or if you remember what this triangle is all about, then we would know that that opposite side is 1. So what angle here would create a 1, 1, root 2 triangle? Very good. Our angle would have to be 45 in both those triangles, because 1, 1, root 2 is 45 degrees. So our value in quadrant 3, well, we have a reference angle, or quadrant 2, I'm sorry. So we have a reference angle of 45, but we want to see what's the angle that's going to land us there. So how would we find that out? Very good. We would do 180 minus our reference angle. So in quadrant 2, our angle is 135. So quadrant 3, we have our reference angle. That's this part, but we need to get all the way over there. So in quadrant 3, it's 180 plus 45. So that would give us 225. So the two values of theta that give us those cosine values of negative root 2 over 2 is 135 and 225. So let's try the next one. Well, actually, let's try the last one because that one's a little bit harder. So this says secant of theta equals -2. So whenever I have secant, cosecant, or cotangent, I always convert them to their reciprocal functions. So this really is cosine of theta equals -1/2. So we just flip it. So again, we have cosine being negative, so that's in the same quadrants we just worked on. So quadrant 2 and 3. So in quadrant 2 and 3, we have cosine being -1/2. So -1 adjacent, 2 on the hypotenuse. So if you do the Pythagorean theorem, or if you remember your side ratios, that would leave opposite to be root 3. So what angle measure is opposite of root 3? Very good, 60. So our reference angles are 60. So we're going to do the same thing we did for the last one. To figure out what this angle measure would be is 180 minus 60, so 120. And then to find what this angle measure would be, it would be 180 plus our reference angle, so 240. So the two values of theta that would give us negative 1/2 are 120 and 240. So go ahead and pause and try that last one. Okay, welcome back. So we had sine being negative, so that's quadrants 3 and 4. And we have root 3, so across from root 3 gives us a reference angle of 60. So to get that value in quadrant 3, it's 180 plus 60. To get the one in quadrant 4, 360 minus 60. So that gives us values of 240 and 300. So make sure you write down any questions you have, and we'll go over them in class tomorrow. Warner out.